So yesterday we had seen what was that? The class, right? About the class. There are many other methods within the class. I think yesterday we had seen class dot for name and get declared methods, right? This is basically these things are basically used to get all the members of a class or object. How many methods are there? How many constructors are there? What are the different return types for each method, and what is the class name and what is the object, right? Because we will be creating the objects for so many classes, right? So if you want to find out particular object belongs to which class, right, all such things can be found with the either class or object, right? So this is all about the object class. So we had learned about all these things: wait, notify, notify all. These are the part of the object class. These three are part of the object class but belongs to the concept called multi-threading. Okay, so when we are covering the multi-threading, we'll learn about all these three methods, right? All others we had covered from 1 to 6. These three we'll cover in our next topic, that is multi-threading. So any doubts in this object class so far? No, we'll quickly learn something about enhanced for loop. Enhanced. Write a simple program. Mm, sorry, we'll learn this at the later stage. This is not relevant at this moment. I'll delete it for now. We'll move to the multi-threading directly. Okay, I think somewhere we have learned this multi-threading already. Create a new package, multi-threading -2, because I already had one multi-threading which I had covered some time back only for few people. That's the reason. So now I'll keep it multi-threading 2. Where is that? Where did it go? Multi-threading. Multi-threading. We'll create some nodes first. So what is multi-threading? Multiple blocks or portions of a program are executing simultaneously. Simultaneously. Guys, please put some extra focus here. This is a bit a tricky concept, right? But it is important to understand. Simultaneously, multiple threads will be under the same processor. There are basically two types of threads. One is daemon thread, which we just heard in our previous classes. The second one is user threads. Okay. Daemon thread. So this is a thread which is depending on its parent thread life. If parent thread is leaving on execution, then one thread also leaves. Okay, it's the user thread. This thread doesn't depend on the parent thread. On the parent thread life. Alright, so just try to understand in simple language. All these are very technical words, right? So first of all, what is multi-threading? Multi-threading is nothing but multitasking. Everybody must be knowing the multitasking in simple terms. What does multitasking? Doing the multiple things simultaneously, not sequentially, right? If you do the sequentially, that means that is a sequential processing. If you are doing the multiple things simultaneously, that is called as the multitasking. So multitasking can be achieved in Java by using the multi-threading concept. Multi-threading, multi-threading, right? So here we are talking about the threads. Threads are nothing but each task, right? Not even each task. It's a part of the processor, right? Which will be created for doing the multiple tasks. Each thread will take care of different tasks here, right? So in general, there are basically two threads. One is daemon thread. Two types of threads. One is the daemon threads, and the second one is the user threads. So daemon thread is nothing but it's a thread which is available in Java, which comes as part of the JDK already, and it depends on the execution of the parent thread life. Okay, it depends on the parent thread life. You cannot control it. You cannot control the daemon thread. But coming to the user thread, so as a user, as a developer, we also can create any number of threads in our Java programs. Any number of threads in our Java programs. So if a developer is creating the threads, then those are called as user threads, and parent thread doesn't have any control on it. Parent thread doesn't have any control on it. Right? So as a developer, we should control the user threads completely. Okay. Let's start with the simple program class A. SVM. So we already learned about for loop, right? Int I equal to 0, I less than 5, I plus 2. So of I. create another thing equal to 10 less than 15 plus. So top I. So what will be the output when I try to print this? What will be the output when I try to print this?
0 to 4 and 10 to 14.
Yeah, 0 to 4 and 10 to 14. So first it prints from 0 to 4, and once that is completed, then it goes with the 10 to 14, right? Let's run and verify. So this is the expected output. So very simple thing. Let's try to write another program which has the multi-threading concept. So basically multi-threading can be achieved in two ways. One is by extending the thread class, and the second one is by implementing the runnable interface. So class B extends thread. You see, thread is a class which is available in Java by default, right? It is available in the java.lang package. It has all these variables and methods in it. Right? Has all these methods in it. It has around 2000 lines of code in this class. Okay, let's go back to our class. Now, what I do is public void run method. Public void run method. So here I will write for int I equal to 0, I less than 10, or maybe 5 itself, plus plus. Okay. Now I'll create another class as a manager, that is the B manager class. So here I simply write a main method svm b1 equal to new b b1 dot. See here, when I say b1 dot, it is showing a lot of methods. That is the run method, check access, get context loader, get ID, get name, get priority, right? All these methods are related to the multi-threading. All these methods are related to the multi-threading. For example, in the class B, if you don't have this, right? If you don't have this, if you see b1 dot, you will get only few methods. You will get only few methods. Run method is already available. That is the reason it is showing the run. It is showing the run method. Right? Other than that, all the methods that were available in the object class. But if you put, excuse me, if you put it back, you will have these methods in the object. Right? All these methods are related to the thread class, whatever you see here, right? So all these methods will come to the class B because we are extending the class thread. That means whatever the variables or methods are there in the thread class, all of them will be available here. Now I'll call start method. Okay, out of so many methods, I call the start method. Okay. Then write another for loop here. Int I equal to 10, t less than 15, out of so what will be the output now? We are calling the start method. Let's see what is there inside the start method. Right? It goes to the thread class. So inside the start method, what do we have? We have this much code. At this moment, let's not try to understand and then confuse. Let's leave it. Right? So the start method will call the run method internally. Right? Whenever you call the start method on an object which is extending the class thread, this will call the run method. That means this will create a thread. v1 dot start. That means here we are creating the thread. Creating the thread. Start means starting the thread, creating the thread. Okay. So if you understand this way, like if the start method is calling the run method, then obviously the run method will execute here, and once the run method is executes, then it goes to this for loop, right? That's how our understanding should be, correct? Any confusion here? Let's try to run the program and see the output. So first it has to print 0 to 4, then it should start with 10 to 14.
Amma, in the program B, you have entered 1 instead of I in the for loop.
In the program B,
B.
equal to 0. Oh, that's the reason. If you see here in the bottom, that's what I was wondering. It is running in the infinite loop. It was running in the infinite loop. See, 1 is always less than 5. That's the reason it was keep on running. Sorry, I just fixed it. Let's run it again. Okay, so the execution is completed. If you see here, first it started with 10, 11, 12, 13, 14, and then 0, 1, 2, 3, 4, right? So the run method did not call first. First, this has been executed, and then this has been executed. Let's run the program and then see again. Each and every time, please try to notice the output. I think this is a different output, right? First it started with 10, 11, 12, and then in between the first for loop that is there in the run method has executed, right? And then again it has come back to the 10 to 14, right? Let's run the program again. This is a different sequence. Let's run it again. This is what we expected for the first time, right? But this happened only once now. Let's run it again. Again the same thing. Let's run it again. Again now. Again it is slightly different. First it started with the second one and then immediately it went to the first one and then again continued the second one. Let's run it again. Now this has first one has completed first and then the second one. So like this, usually output should change whenever we make any changes in the code, right? But here, without making any changes in the code, the output is changing, the sequence is changing. That means basically whenever we call this, right, b1 dot start method, that means a new thread is getting created, new thread is getting created. That means this will be executing by one thread and this will be executing by another thread. This is not part of the run method, right? So whatever you put inside the run method, all of that code will belongs to one thread. So basically there are two threads are running. One thread is responsible for this for loop, right? And another thread is responsible for this for loop, right? Since both the threads are doing its job simultaneously, right, together at the same time, we are seeing the output mixed up, right? So we cannot have a fixed output in this scenario. We cannot have a fixed output. No output is right, no output is wrong here, right? So based on the system memory and how these threads are behaving internally in the laptop, right, so they will decide the output. We don't have any control, we don't have any control. Creating a thread or the child thread, we also called as a child thread. So this will be executing by the main thread. So whatever the code that is there within the main method is called as the main thread. Is called as the main thread. Clear? Thread can be sorted multi-threading. Multi-threading can be implemented in two ways. One is by extending thread class. Second one is by implementing runnable interface. Implementing runnable interface. We need to extend thread class, override the run method. Override the run method. New thread will be started by calling the start method. By calling the start method. Start method internally calls the run method. Internally calls the run method. Okay, internally calls the run method. Let's see another simple. Any doubts, guys, so far? I'm going to put exactly the same piece of code manager. I'll copy the same code from the B manager. C. Now we should go to the class C and extends the thread class. Close the B. Let's split it up vertically. Right. So here in place of start method, I call the run method. Okay. What will happen now? What will be the output now? Will it be like the previous program or it will be in the normal, right? Let's run the program and then see the output. 0, 1, 2, 3, 4. So that means first this for loop has executed, right? We are calling the run method and then the next for loop is executing, right? Let's run it again. Again, same thing 0 to 4 and 10 to 14. And run it again. Again, same thing. Run it again. Again, same thing. I'll run it again. Again, same thing. So you run this 100 times or 1000 times or 1 lakh times or 1 million times or 1 billion times, you always get the same output here in this case. Okay. What is the difference between the class B and class C? Right? What is the difference between class B and class C? In the class, sorry, in the class B manager, right? What is the difference between B manager and C manager, right? In the B manager, we are actually creating the thread and then starting the thread by calling the start method. Okay, so if you call the start method, that's when the thread will be created and then there will be two threads and then both the threads will be executing. But if you call the run method directly, right, if you call the run method directly, run method will execute as a normal method, not as a thread, not as a thread. This is not a thread. Here we are not starting the thread. Thread can be started only by calling the start method. Thread can be started only by calling the start method. But if you call the run method will execute as a normal method. As a normal method. Here in the B manager, it is always simultaneous execution. Simultaneous execution. Simultaneous execution. But the class C is the sequential execution. There are no threads here. We are not starting the thread. We are creating the thread, that is by extending the class thread, but we are not starting the thread. Please see the difference, guys. First, we need to, if we want the multi-threading feature to be enabled in our programs, first we need to extend the thread class. That means the thread can be created, but that cannot be started. A thread can be started its execution only by calling the start method. Only by calling the start method. This is the only way to start the threads. Otherwise, if you directly call the run method, this will be treated as a normal method. This will be treated as a normal method, not as a method belongs to the thread class. Clear? Any confusion here? Very important here. In the interviews, they will put both the scenarios in front of you, this one and this one. Then they will ask you to explain how this works, right? So you need to give this explanation, which will be simultaneous and which will be sequential, and Why is that? Any confusion? We call the run method directly, then run method will behave as a normal method, doesn't start the thread. Thread can be started by calling the start method only. Start method only. Here in the class C, when you do this, there will be only one thread. That is the main thread. That is the main thread. But in class B, there will be two threads. One is the main thread, another one is the B1 thread. Any confusion so far? Let's see another program, class B. Where is the unsplit? Class B. I am again extending class. Create another class. I am not going to keep any method here. Okay. Create another class. DET manage. Main method get dd1 equal to out of one dot out of one dot in out of one dot get array one dot is in. You see, we don't have all these methods in our class D, right? We don't have the class D is completely empty, but still we are able to call some methods, that is get ID, get name, get priority, and is daemon, right? That means all these methods are available in the class thread again. Yes, these are all available in the class thread here. Okay, name, priority, and for all of that there are the corresponding methods. Okay, whenever we create any thread, each thread will have some properties. Whenever you create a thread, each thread will have some properties, right? Out of that, id, name, priority, and then is daemon, right? And then there are many other properties are there like this. You can just put d1 dot, you can see all the other properties. For example, is alive, that means a thread is alive or it is dead. Alive or dead. When you call the start method, thread is in the live state. When you call the terminate method, which we will learn later, then the thread will become the dead state, right? So thread life cycle is nothing but a human being. Thread is nothing but a human being here. And then is interrupted, join, which we are going to learn all of them, right? For now, our interest is to learn only these four properties. Okay, let's run the program and see the output. See, the first one d1 dot get id has given number 11, and then the name is thread 0. Name of the thread is thread 0. Priority of this thread is 5, and is daemon, this is the user thread, right? So whatever you create the thread, those are the user threads. That's the reason it's not a daemon thread. It gives false. Clear? So this ID will be the unique ID. This will be a unique ID. Let's say you create 100 threads here, right? Then each and every thread will have its own unique ID. Each and every thread will have its own unique ID. Right? Let's write some notes here. Whenever threads are created, they get a lot of properties. Lot of properties. That is a unique ID, unique ID, and this cannot be modified later. Not be modified later. The second one is name. Can be modified later. One is the priority. The priority also can be modified later. Fourth one that we learned is the daemon type. Daemon type. Okay. By default it is false, but if it is false, then it is what? User thread. It is user thread. Threadness feature. Threadness feature is nothing but getting the separate CPU time to thread scheduler. As threadness feature, then it is set to be in newborn state. Newborn state. Thread scheduler is considering CPU time only for registered registered threads, not for all the not for all the. How do we register the thread? A thread can be registered by calling start. So as I had explained, whenever we create a thread, it gets a lot of properties. Out of them, these four are the little important properties where the idea of the thread that will be unique and that can never be modified later. but the name, yes, you can modify it later. The priority also you can modify it later. So the daemon type, it is always false by default. If it is false, that means that is a user thread. Even this also can be modified later. And then we are talking about threadness feature. Threadness feature is nothing but we get the threadness feature when we extend the thread class. That means that we get some separate CPU time. So we all know the CPU in our laptops, right, or in our systems, right? So that means this thread is going to get a separate CPU through the thread scheduler. All this scheduling, right? For example, we have seen in the class B and B manager, right? It was each time it was executing in a different sequence, right? So all of that is being controlled by what? Thread scheduler. Thread scheduler is responsible for allocating the memory and time based on all the resources within the laptop. For example, in my laptop, for now, other than this class B or B manager or whatever it is running, there are many other threads are running. What are those threads? My IntelliJ is also a thread. We are running the IntelliJ, right? This is also a thread. I am using the Google Chrome. This is also a thread. And I am using another tool for the recording the session. This is also another thread, right? Meanwhile, there is a calendar is open in my laptop. This is also another thread, right? If I open my WhatsApp here in my laptop, this is also another thread, right? So each and everything will be a thread here, right? When we open a thread or start a thread, thread scheduler register the thread and then plan the or allocate the resources for each and every thread, right? So thread scheduler is responsible for registering the threads and allocating the memory and CPU time within the system. Any doubts, guys? Little bit tricky, but you need to go one by one slowly. Then you'll understand. We'll see one simple program. Class E friends head void run method. Here for I equal to 0 again, I less than 5, I equal to I create the manager class now. Manager. Yes, one equal to 1 dot. Again, I create E2 equal to new E2 dot. And I create another new E3 equal to new E3 dot. Cancel. Done. What is happening here? Class E is extending a class thread. Yes or no? Class E is extending the thread class. Right? Extending the thread class. That means it has the threadness feature. And then we are calling the start method. That means here there is one new thread is starting here. And again I am creating another object, and on the second object also I am calling the start method. That means here the second thread is starting. Again I am creating another object e3, and then I am calling again the method start. That means again here the third thread is starting. Let's run the program and then see the output. So this will be sequential or simultaneous. See, it is running 0 1 2 3 4 0 1 2 3 4 done, and then 0 1 2 3 4. I'll run it again. Again the same thing. I'll run it again. Again the same thing. Again the same thing. Again the same thing. See, now it is changed. Done went to the last. That means this is the main thread. All these three are the user threads that we had created, right? So I don't know which belongs to which one here. E1 belongs to what and E2 belongs to what, right? I don't know where E1 is starting, where E2 is starting, or where E3 is starting. Right? Again the same thing. Again the same thing. Now again it is changed to the first state, right? So basically here also you cannot expect the fixed output. This is also simultaneous. Simultaneous. We can start any number of threads. We can start any number of threads. Start any number of threads. Right? Calling start method on each object. On each object. Each object. Clear? Simple program. I'll just copy paste. Yep. And yep, manager. I'll just take this, copy this. I create a new class. Yep, manager. Just here. One dot run and one dot top. What am I doing here? I'm creating a class F with the threadness feature. Here we have overridden the run method, printing from 0 to 4, right? And then here I am calling the run method as a normal method. This will be normal method execution. Normal method execution. But here it will be a starting the thread. Here we are starting the thread. Let's run the program and see the output. 0 1 2 3 4 0 1 2 3 4. Here this will be output will be always same here because thread is starting only in the end. After executing all these things, thread is coming and starting here, right? If you had anything after this, then this will mix up. Otherwise, thread is starting after executing all the previous content. The normal execution is completed and then we are starting the thread, right? So here thread will be the last one to execute. Last one to execute. It should be F, right? Otherwise, output is not going to change. The same code. For example, I will start F1 dot F1 dot comment this out. Create a new class. Class B. I will put this. B manager. See this. Here. Run the program and then see the output. We had got the error. We had got the error. See, first it has printed 0, 1, 2, 3, 4, and then again it is giving some exception, that is illegal thread state exception. Illegal thread state exception. If you run it again you will get the same thing, because you cannot start the same thread multiple times. Illegal thread state exception. We cannot start the same thread multiple times. Not start the same thread multiple times. We can start any number of threads, but we cannot start the same thread multiple times. When you have, this is also another important scenario during the interviews. They will give the code snippet like this, and then immediately you should say we cannot start the same thread multiple times. Each thread can be started only once. If you look at the previous program, right, F manager, here we are starting the thread only once, but we are calling the run method as a normal method for the first time, and then we are starting the thread. These are two different things, both are not same. Clear? Any confusion, guys? I'll stop it here. I will continue tomorrow. Please do enough practice, right? Otherwise, you will not get this.